everyone. This is Vijayalakshmi Sugnali from WinMaths. In this session, we have to discuss the multiple choice question for second PUC Mathematics. WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and competitive exams. This channel helps those who are studying PUC and guide you in the making a PUC preparation for various competitive exams. Here, in this session, we have to discuss the multiple choice questions for inverse trigonometric functions. Okay, here in this chapter, there are some important problems are there. Okay, we have to solve all the multiple choice questions here. There is a first one question is the principal branch of f of x is equals to sine inverse of x. Okay, here we have to find the principal value of the sine inverse function. Here for sine inverse function, there is an angle between minus 90 degree to 90 degree. There is a close interval minus 90 degree to 90 degree. Here this denotes the close interval. The option number C is correct here. Okay. Always the condition is lies between minus 90 degree less than or is equals to x less than or is equals to 90 degree. Okay. Here this is the inverse function for sine function. Then there is a domain of sine inverse function minus 90 to 90. There is a close interval here minus 90. The sign of minus 90 will be minus 1. The option number D. The option number D is correct for second question. Then the principal value of cos inverse x. The principal value of the cos inverse function is always lies between the 0 to pi. Okay. Here the closed interval 0 to pi. The 90 degree denotes the 0 and minus 90 denotes the 0 and plus 90 denotes the pi. Okay. Here by using this one, I can say the principal value of the cos inverse function is 0 to pi. The option number D is correct. Here, the domain of cos inverse function. We know that the principal value. Okay, what is the cos 90 degree? Okay, cos 90 degree will be minus 1. Sorry, cos 90 minus 90 will be minus 1 and here 180 cos 90 will be minus 1 and cos 180 will be 1. Okay, here this one denotes the minus 1 to 1. Okay, this is the cos function. The option number D is correct. Next, move on the tan inverse function. Tan inverse function shows the open interval. Tan inverse shows the open interval for 90 degree to 90 degree. Okay, here pi by 2 indicates the 90 degree minus 90 to 90 degree. Again, the domain of the tan inverse function. The domain of the tan inverse function is a real number. Okay, real number always indicates the minus infinity to infinity. Real number indicates minus infinity to infinity. Then domain of the cot inverse. Same. The domain of the cot inverse also indicates the real number. What is the principal value of cot inverse? The principal value of the cot inverse is open interval of 0 to pi. Open interval of 0 to pi. Here, that is open interval of 0 to pi. The option number B is correct. Then the range of sec inverse x is the range. Sometimes they ask for range, otherwise principal value. Both are the meaning same. Both the words giving the same meaning. The principal value range both are same. The range of the sec inverse x. Okay, secant inverse of secant function. Here that is the open interval of 0 to pi except 90 degree. The open interval 0 to, sorry, close interval 0 to pi except 90 degree. It includes all the values of 0 to pi except 90 degree. Okay, the option number C is correct. Then question number 10. The principal. Already I say the principal and range both are same. Again, here the value is close interval of, okay, close interval of 0 to pi minus pi by 2 except 90 degree. Then, what is the principal value of cosec function? Cosec inverse of x is here. For sec function, there is a close interval of 0 to pi. Here, cosec inverse of function, there is a close interval of 90 degree to 90 degree except 0. Okay. Here, close interval of minus 90 to 90 except 0. The option number C is correct. Then the domain of cosec inverse x is, the domain of cosec inverse x is here r minus the real number minus except minus 1 to 1. There is a open interval minus 1 to 1. The option number B is correct. The option number B is correct. Then here by giving the tabular column. Here this tabular column completely denotes the domain and range of all the inverse trigonometric function. Have to remember the table. Okay. Don't forget this table because from this table there are 12 questions are there. Okay. So we have to remember these domains and range of the inverse trigonometric functions. Now let's move on the next question. Okay. Before going to discuss the questions, I can discuss the tabular column. Here, this tabular column denotes the trigonometric functions with their degree and the values. Okay. Here, this 0 degree. Here, there is a 0 degree. Okay. Now, 0 degree means 0 radian. Here, pi by 6, pi by 4, pi by 3, pi by 2, pi denotes the angles in the radian form. Angles are in the radian form. Okay. Here, 0 degree. Pi by 6. That is, pi by 6 will be 30 degree. And pi by 4. 5 by 4 denotes the 45 degree. And this one, okay, pi by 3. Pi by 3 denotes the 60 degree. Pi by 3 denotes the 60 degree. Next, similarly, pi by 2 denotes the 90 degree and pi denotes the 180 degree. Okay, here these are the radian form. Okay, pi by 6, pi by 4, pi by 3 all are radian form. Now, wait 1 second. Now, 0, sine 0, okay. Sine 0 degree will be 0. Sine pi by 6 is 1 by 2. Sine pi by 3, 5 by 4 is 1 by 2. Pi by 3 is root 3 by 2. There is a shortcut tricks for remembering the angles here. Okay. First, there is always starting the angles from, the angles are taken in a ascending order, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay, these are the ascending form. Okay, here is first taken sine function, cos function and tan function. Okay, here I can give the one formula. Here sine 0 degree always denotes the 0 only. Then sine 30 degree, first you have to make the values here. Remember the values. Sine 0 will be 0 degree. Then sine 30, that is 1 by 2. First taken 1 by 2. Then 45 means 1 by root 2. 1 by 2, 1 by root 2. And 60 will be root 3 by 2. Then sine 90 degree will be 1. Again, taking the all the values in reverse order. Okay. First cos 90 will be 1. Then 30. Write all the values in reverse order. 1 root 3 by 2, 1 by root 2 and 1 by 2. Here 0. This is the cos function. Okay. Next, for tan function, we already know the property. Tan x is equals to sine by cos. Okay. Here, similar property I have used here. 0 by 1. 0 by anything, the value denotes 0. Okay. Here, 1 by 2 divided by 1 by root 2. 2 get cancelled, we will get 1 by root 3. Again, here 1 by 2, 1 by root 2, 1 by root 2 get cancelled, we have values 1. Root 3 by 2, 1 by 2, 2 get cancelled, the value is root 3. 1 by 0, we know that not defined. 1 by 0, not defined. Okay. But like this, you have to construct the table. Then finally, the 90 degree, the pi value 180 degree. Here always sine 0 is 0, sine 180 is also 0. Here cos 0 is 1, 180 means minus 1, 0. All the values are same. Okay, like this, you have to remember the table. Okay, after remembering the table and all the values, you can solve all the problems easily. Okay, I will remove the erasing the words here. Okay, now there is a first one 13 question. What is the principal value of sine inverse minus 1 by 2? Okay. Before going to solve the problem, there are some basics inverse trigonometric properties are there. Basic properties of the inverse trigonometric function. That is, that is sine inverse of negative angle. Sine inverse of minus theta is equals to minus sine inverse of theta. Tan inverse of negative theta is equals to minus tan inverse of theta. Again, cosec inverse of cosec cosec inverse of negative theta is equals to minus of cosec inverse theta. Okay. Here sine inverse of minus theta. Then cos sine inverse of minus theta is equals to minus theta. Cos similarly cos inverse of theta. Okay. That is cos inverse of negative angle is equals to pi minus cos inverse of theta. Then sec inverse of negative theta is equals to pi minus sec inverse of theta. Then cot inverse of minus theta is equals to pi minus cot inverse of theta. Okay, these are the basic properties for solving the inverse trigonometric functions. Okay, I can use the basic properties here For the 13th question, the value of sine inverse of negative theta. The value of sine inverse of negative theta, I can taking the property here. I can use the property. By using the property, I am directly written negative of sine inverse 1 by 2. What is the value of my sine inverse 1 by 2? That is pi by 6. Here, there is a negative here and pi by 6. Sine inverse of 1 by 2 is pi by 6. The option number A is correct. That is minus of pi by 6. Then, the principal value of cos inverse of minus 1 by 2. According to the property, I can use here. I can use directly cos inverse of minus 1. Okay, cos inverse of minus 1 by 2 can be written as pi minus cos inverse of 1 by 2. What is the value of cos inverse 1 by 2? Here there is a cos inverse of 1 by 2 is pi by 3. I can use here. While taking pi minus pi by 3, I can take the LCM, that is 3 into pi minus pi by 3. What is the value? 3 pi minus pi by 3 is equals to 2 pi by 3. Okay, this is the value of the cos inverse minus 1 by 2. The option number D is correct. Then, principal value of cosec inverse of minus root 2. We already know that cosec inverse, okay, cosec x is equals to 1 divided by sin x. Okay, here I can use this property. Cosec inverse can be written as 1 by of sine function. Same, I can use here the cosec inverse of, I can use the table here. Okay, here in the table there is no cosec function, but I can use the sine function here. That's why. What is the sine of 1 by root 2? That is pi by 4. According to the property, what can written? Pi minus cosec of root 2. What is the cosec inverse of root 2? Pi minus here 1 by root 2. That is, while taking the inverse, it is root 2. Okay. Therefore, what is the cosec inverse of root 2 is pi by 4. Pi minus pi by 4. I can take the LCM. 4 into 5, 4 pi minus pi by 4, pi by 4. 4 pi minus pi, that is 3 pi by 4. The option number 3 is correct. The option number 3 is correct. Now, I can solve the next one problem. Question number 16. Okay. Question number 16. Here, what is the tan inverse of minus 1? Tan inverse of minus 1, by using the property, what can written for tan function? That is minus of tan inverse 1. What is the value of tan inverse of 1? The angle will be pi by 4. Here there is a minus pi by 4. The option number B is correct. The value of tan inverse of minus 1 is minus pi by 4. Now, next, question number 17. Question number 17. What is the value of tan inverse 1 plus cos inverse of minus 1 by 2 and sine inverse of minus 1 by 2? Okay, here we can solve already these the values. What is the tan inverse of 1? I can solve directly. Tan inverse of 1 will be pi by 4. Here there is a plus symbol. I can written. Next, cos inverse of negative theta. I can use the property, that is pi minus. What is the value of 1 by 2? 1 by 2 tan. That is cos of 1 by 2 is pi by 3. Pi minus pi by 3. Then here there is a plus. What is the sine inverse of minus? According to the property, I can write minus. Sine inverse of 1 by 2 is pi by 6. Now I can solve here. Pi by 4. Here 3 pi minus pi. That is 2 pi by 3 plus 2 pi by 3. Again plus into minus. Minus pi by 6. Okay. Here pi by 4 plus 2 pi by 3 minus pi by 6. We cannot add directly. So I will take the LCM. Okay. I will take the LCM 436. While taking the LCM of 436. Taking 2. 2 2 is a 4. 3 same. 2 3 is a 6. I can again taking 3. 2. 3 1s are 3 1. While multiplying the values, 2 3s are 6, 6 2s are 12. The LCM will be 12. So I can multiply here. 4 3s are 12, 3 4s are 12, 6 2s are. Okay, next 3 into pi, 3 pi plus 2 pi into 4, 8 pi plus 2. Sorry, here there is a minus. Okay, I can use the minus here. 2 into pi minus 2 pi. Then 3 pi plus 8, 11. 11 minus 2, 9 pi by 12. So 3 3s are 9, 3 4s are 12. Okay, the value is 3 pi by 4. Where is the option? The option number B is correct. That is 3 pi plus 3 pi by 4. Now, the value of tan inverse of root 3 plus sec inverse of root 3. I can solve here. What is the tan inverse of root 3? Tan inverse of root 3 is pi by 3. Tan inverse of root 3 is pi by 3 plus sec inverse of 2. Sec function, there is a property pi minus sec inverse of 2. Sec inverse of 2 is pi by 3. Sec inverse of 2 is pi by 3. Now, while solving here, pi by 3 minus here, taking LCM with sec inverse of minus 2. Okay. Here, pi by 3 plus 3 into pi, 3 pi minus pi. That is 2 pi by 3 is equal to. Now, the bases are same. So, I can take 3 pi plus 2 pi. That is 3 pi. 3 3 get cancelled. You will get the value pi. The option number 1 is correct. The value of tan inverse of root 3 plus sec inverse of minus 2 is pi. Then the value of cos inverse 1 by 2 plus 2 into sine inverse of 1 by 2. I can solve here. That is cos inverse of 1 by 2. That is cos inverse of 1 by 2 is pi by 3 plus 2 into sine inverse of 1 by 2. Sine inverse of 1 by 2 is pi by 6. First have to take the multiplication. 2 ones are 2 3s are. Then you will get pi by 3. Here there is a pi by 3. Pi by 3, pi by 3. The values are same. 3 bases are same. Here pi plus pi. 2 pi by 3. The option number 1 is correct. The option number 1 is correct. The value of tan inverse root 3. The value of tan inverse of root 3 is tan inverse of root 3 is pi by 3. Again, cot inverse of root 3. I can use the property here. That is pi minus. What is the value of cot root 3? Cot root 3 will be 1 by 6. Pi by 6. That is pi by 6. Now I can solve here. 6 into pi. 6 pi minus pi. 5 by. Here there is a pi by 3 plus 6 into pi. 6 pi minus pi. 5 pi by 6. While bases are different, we have to take the LCM. That is, LCM is 6. 3 2s are 6 1s are 2 into pi. 2 pi plus 5 pi. Now we have to add here 2 pi plus 5 pi, 7 pi by 6. The option number D is correct. The option number D is correct here. Next, we will move on the next question. Question number 21. Sine of pi by 3 minus sine inverse of 1 by 2. Okay, I can solve here. First, okay, first I can take sine function of, I will kept pi by 3 for some times. Again, sine inverse of minus 1 by 2. According to the property, what can written here? There is a minus. Here from there is a minus. Minus into minus, it becomes plus. What is the sine inverse of 1 by 2? The value will be pi by 6. Now bases are different. So I can take the LCM. Sine function is outside. So while taking the LCM, I will multiply 2 here and 1 because the LCM is 6. 2 into pi, 2 pi plus pi into 1, pi. 2 pi plus pi, 3 pi. Sine of 3 pi by 6. 3 ones are 3 twos are. Then sine of pi by 2. That is sine 90 degree. Sine 90 degree will be 1. Sine 90 degree will be 1. The option number D is correct. Now, the principal value of cos inverse of cos x. Okay. The principal value of cos inverse of cos x. Here, the value is, while solving the problem, the principal value of cos inverse of x. Okay. While taking the value here, that is cos inverse of cos x. I will solve this later. Then the principal value of sine inverse of sine 2 pi by 3. Okay. Here sine inverse of sine 2 pi by 3. Okay. Sorry. Here there is a cos inverse of cos x. According to the property, the answer is x. But here there is some points, some values are there. But in place of x, here in place of x, I have to take the value 7 pi by 6. Okay. That is cos inverse of cos 7 pi by 6. For this one, what is the value of, what is the principal value? Here we have the principal value for cos inverse function. So make 7 pi by 6 in the form of domain. Okay, make the 7 pi by 6 in the form of domain in the range 0 to pi. Okay, so I can take this. Here there is a numerator and denominator. Numerator is bigger and denominator is smaller. So I can write this one as a pi minus the pi plus pi by 6. I can write it 7 pi by 6 can be written as pi plus pi by 6. Again, you will take the LCM, you will get 7 pi by 6. Okay, 6 into pi, 6 pi plus pi, 7 pi. So I can return this one cos inverse of cos pi by 6. Cos inverse of cos 7 pi by 6 can be written as cos inverse of cos pi plus pi by 6. Therefore, the principal value is I have to taken pi by 6. This is the principal value of the cos inverse of cos 7 pi by 6. Again, for this one, the principal value of the sine inverse of sine 2 pi by 3 can be written as 2 pi by 3 according to the property, but 2 pi by 3 is not belongs to the range. Okay, 2 pi by 3 is not belongs to the range minus pi by 2, pi by 2. So I can return this one in the range. So 2 pi by 3 can be written as sine inverse of sine. Here numerator is smaller, the denominator is bigger. I can take this one as pi minus pi by 3. Here 3 into pi, 3 pi, 3 minus 1, 2 pi by 3. Therefore, the answer is pi by 3. Pi by 3 which is belongs to this one range. The answer is pi by 3. Similarly here the value x is 7 pi by 6. 7 pi by 6 is not in the range, not in the range 0 to pi. Here this is not belongs to in this range 7 pi by 6. So I can take it as a pi plus pi by 6. Then the pi by 6 value is, the pi by 6 value is 30 degree. 30 degrees belongs to this range. Therefore, the principal of cos inverse of cos x is pi by 6. Similarly, the principal value of sine inverse sine 2 pi by 3 is pi by 3. Again, the principal value of the sine inverse 3 pi by 5 can be written as, here this one is, so 3 pi by 5. 3 pi by 5 not belongs to the range minus pi by 2, pi by 2. Okay, this 3 pi by 2 divided by not belongs to this one range. So I can return this one in a balancing manner. Okay, I can return as 3. This one is the smaller and this one is the greater. So I can use here 3 pi by 5. So I can split into pi minus 5 by 5. Here, this is not balanced. Okay, we want pi into 5. 5 pi minus, when you get same result. Okay, 3 pi by 5 can be written as 5 pi minus 3 pi. Okay, 5 pi minus 3 pi. You will not get the result. So I will take 2 pi. That is pi minus 2 pi by 5. So while again solving, you will get 3 pi by 5. 5 into pi, 5 minus 2, 3. Okay, the answer you will get same. Therefore, the 2 pi by 5 value will be belongs to this range. That is 3 into 180, or 2 into 180. 360 divided by 5d. Okay, here I can solve here 5 ones are 5 sevens are again 10, 5 twos are 72 degree, which is belongs to this range. The answer is 2 pi by 5. 2 pi by 5. Now, the value of sine of tan inverse x. The value of sine of tan inverse x. The value mod x is always less than or is equal to 1 is equals to. Now, I can solve here. First, I will consider the sine of tan inverse x. Sine of tan inverse x, taking it as a theta. So tan inverse x is here. Take sine function on this side, it becomes, okay. Or else sine of tan inverse x can be written taken as x. Okay. Here, while solving the equation, you will get sine is equals to the function sign here, that is tan inverse of x is equals to, now tan inverse of x is equals to theta. So I can take tan inverse of x is equals to theta. Again, you will get sin theta. Okay. Tan inverse of x is equals to theta, you will get sin theta. Now, tan inverse of x is equals to theta can be written as x here. Taking tan function on right side, it becomes tan theta. We already know the angle in the trigonometric function. Okay, this is adjacent side. While taking the rectangular, this is adjacent side, and this one is the opposite. This one is the opposite. This one is the hypotenuse. According to the tan function, we can written tan x is equals to, what is that? Opposite divided by adjacent. Opposite divided by adjacent. No, tan x. Here there is a tan x. Tan theta is equals to x. Okay. What is the opposite value? The adjacent value becomes 1. While taking the values here, the adjacent becomes 1 and the hypotenuse value. Hypotenuse is tan theta is equals to taking x by 1. Tan theta is equals to x by 1. X indicates the x indicates the x indicates the opposite direction and 1 indicates the adjacent. So x by 1. Tan theta is equals to x by 1. You will get by using the Pythagorean theorem. What can written? A, B, C. Here hypotenuse don't know. Opposite will be x. According to the theorem of Pythagorean, AB square is equal to AC square plus CB square. I can solve here. AB square, you already know the value, x square. Then what is the AC square? We don't know. I will kept AC square here plus CB square is 1 square. So x square is equals to AC square. I will take 1 square on left side. It becomes minus 1. But the x value is always taken as 1. Therefore, I can take this one as a plus 1. AC square. We want the value of AC. So AC square, I will take square as a square root. This becomes x square plus 1. And the value opposite is on. The hypotenuse denotes the root of x square. Root of x square plus 1. Now we want the sine theta. Sine theta, because here I can take tan inverse x as a theta, so we'll get the sine theta. What is the sine theta in terms of the trigonometric function? That is opposite upon the opposite upon hypotenuse. Opposite upon hypotenuse. What are the values of the opposite? That is x. What is the value of the hypotenuse? That is root of 1 plus x square or x square plus 1. The option number D is correct. The option number D is correct. Okay. Now, let's move on the question here. That is question number 26. Okay. Here, according to the property. Okay. Here, I can use the property tan inverse of x by y plus tan inverse of x minus y. According to the property. Here, what is the property here? Tan inverse of x plus tan inverse of y is equals to tan inverse of x plus tan inverse of x. By property, I can written tan inverse of x plus y divided by 1, 1 minus xy. Okay. According to the property, I can written tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y divided by 1 minus x into y. Here, the x denotes this bracket and y denotes the bracket. Now, I will take the problem here. While solving the problem, it will goes the lengthy process. Okay, it will go on the lengthy process. I can solve here. First, by the property, I can take x, that is tan inverse of what is the x? That is x by 2 plus here there is a tan inverse of x minus tan inverse of y. So the formula according to the property I can write in place of plus it will taken as a minus tan inverse of x divided by y minus here x minus y divided by x plus y again divided by 1 plus x by y into x minus y x plus y. While solving this one, here taking the cross multiplication, tan inverse of that is x into taking the cross multiplication x square plus x into y minus here y x y into minus plus y into y square divided by y into xy plus y square. Okay, again divided by here there is a 1. So I can take first I will take the multiplication here x into x that is x square minus xy divided by y into vx plus y square. Now here there is a plus xy minus xy get cancelled. Again tan inverse of here x square plus y square divided by xy plus y square. While solving the numerator, while taking the LCM, it becomes yx plus y square, then plus x square minus xy divided by, what is that? Here there is a denominator xy plus y square. Here there is a plus yx minus xy will get cancelled. Then tan inverse of x square plus y square divided by xy plus y square. Similarly, here y square plus x square divided by x into y divided by y square. Here x square plus y square plus x square both are same, get cancelled. We will get tan inverse of 1. What is the value of tan inverse 1? That is pi by 4. Therefore, the option number C is correct. The option number C is correct. Now, here we have to use the property. When you go through property, you will get the definite answers. Okay. Next, question number 27. Of tan square, sec inverse of 2 plus cot square, cosec inverse of 3 is. Okay. Here I cannot use the direct properties. Okay. Here there is a 2 and 3. These are not in the form of standard form. There is no value of sec inverse of 2 and cosec inverse of 3 in a standard angle form, angle table. That's why I can use the identities here. The identities are, the trigonometric identities are sine square x plus cos square x is equals to 1, 1 plus tan square x, 1 plus tan square x is equals to 6 square x. Similarly, 1 plus cos square x is equals to cosec square x. These are the trigonometric identities. Here I can use the identities here in place of tan square. In place of tan square, I can return this one tan in terms of sec, that is sec square of sec inverse of 2. Here taking plus 1 on right side, it becomes minus 1. Similarly, for this cos square can be written as cosec square x, and cosec square of cosec inverse of 3 minus 1. Now I can solve here by using the property. Sec square can be written as sec of sec inverse of 2 whole square. Here minus 1 becomes minus 2 plus cos square of cosec 3 can be written as cosec of cosec inverse in place of x, there is a 3. Okay. Now, by using the property, sec of sec inverse 2 can be written as 2. Here there is a square, that is 2 square minus 2 and plus cosec of cosec inverse whole square. It becomes 3 square. Now solve here. 2 square is 4 minus 2. 3 square is plus 9. 4 minus 2. 2, 2 plus 9, 11. The answer is 11. Okay. The answer is 11. The option number is B. Now, question number 28. That is cos of sine inverse 2 by 5 plus cos inverse of x is equals to 0. We had to find the value of x. Okay. Here, first I can take left side of the cos function taken on right side. It becomes cos inverse. That is sine inverse of 2 by 5 plus cos inverse of x is equals to, here taking cos function on this side, it becomes cos inverse of 0. What is the value of cos inverse 0? It becomes pi by 2. That is cos inverse of 0 is pi by 2. I can use the property, that is sine inverse of x plus cos inverse of x is equals to pi by 2. According to this property, I can compare the value of x and this angle, it becomes 2 divided by 5. The option B, that is 2 by 5 is the correct answer. Now, question number 29. If 3 tan inverse of x plus cot inverse of x is equals to pi by 2. So, I can take 3 tan inverse of can be written as, I can take it, 3 tan inverse can be written as split into 2 tan inverse of x plus tan inverse of x plus cot inverse of x is equals to pi by 2, because we know the property, that is tan inverse of x plus cot inverse of x is equals to pi by 2. So I can replace tan inverse of x plus cot inverse of x is equals to pi by 2. Then 2 into tan inverse of x plus pi by 2 is equals to pi by 2. So pi by 2, pi by 2. Otherwise, I can take 2 tan inverse of x. Taking plus pi by 2 on left side, it becomes minus pi by 2 minus pi by 2, that is 0. Taking 2 on right side, 0 by 2, it is 0. That is tan inverse of x is equals to 0. What is the value of tan 0? Okay, here When tan inverse of x is equals to 0, then taking tan inverse on right side, it becomes tan 0. When the value of tan 0, the value is 0. Okay, tan 0 is 0. Therefore, the value of x is 0. Now, I can take the question number 30. The value of cos of sec inverse x plus cosec inverse of x. Here also I can use the property, that is sec inverse of x plus cosec inverse of x can be replaced by pi by 2. Therefore, cos pi by 2. Cos pi by 2. What is the value of cos 90? What is the value of cos 90? That is 0. Cos 90 is 0. Now, let's move on the next question. Let's move on the next question. Question number 31. The value of cot inverse into 1 divided by root of x square minus 1 if the mod of x is greater than 1. Okay. Now, here I can solve the problem by using the simplest form. So, we have to solve the angle in a simplest form. So, I can replace x by some values, then we will get the results. So, here x square minus 1. We already know the some trigonometric identities. Okay. I can use that one trigonometric identity. I can solve the problem because we have cot function. Already we know the property, that is cot inverse of cot theta can be written as theta. That's why the whole part we want the value cot t. That's why which one value is put as x, then you will get the whole value in place of cot theta. So here I can take the x as a tan. I can take the x is equals to sec theta. That is, here replace x by sec theta. Replace x by sec theta. Therefore, I can replace here, that is cot inverse of 1 divided by root of sec square theta minus 1. According to the identities, I can written 1 divided by root of sec square theta minus 1 can be written as tan theta. Okay. Tan square theta, sec square theta minus 1 can be written as tan square theta. Here square and root get cancelled. We have cot inverse of 1 by tan theta. Now, that tan 1 by tan theta can be written as cot inverse of cot theta. We will get the result by using the property. I can return theta. We want the theta value. But here we have taking the x is equals to sec theta. Taking sec function on left side, it becomes sec inverse of x is equals to theta. Therefore, theta value becomes sec inverse of x. Therefore, the value of cot inverse of 1 divided by root of x square minus 1 can be written as sec inverse of x. This is the result of the given problem. Okay. Now, question number 32. Tan inverse of cos x divided by 1 minus sin x. Okay. Here, tan inverse is equals to into cos x divided by 1 minus sin x. Now, I can erase the values here. That is because I want some. Here the answer is second inverse. Now, taking tan inverse of cos x divided by 1 minus sin x. Okay. Now, here this part can be written as tan theta. Okay. Make the cos x divided by 1 minus sin x in terms of tan function. Okay, in terms of tan function by using the some properties. Now I can use here tan inverse cos x. There are four properties are there for cos 2x. Okay, there are four basic properties for cos 2x. One is cos 2x can be written as cos square x minus sin square x. Again, it can be written as 1 minus 2 sin square x. Again, 2 cos square x minus 1. These are the basic properties for solving the cos 2x. Okay, I can use the first one property here, cos square. Here in place of cos 2x, here there is a cos x. That's why I can take by using the allied angle, making the angle divide by 2. So 2 to get cancelled, we have cos x. That's why I can divide whole by 2. That is cos square x by 2 minus sin square x by 2 divided by 1 minus, again sin 2x can be written as 2 cos x by 2 into sin x by 2, because there is a one formula for sin 2x I can use here. Similarly, tan inverse of cos square x by 2 minus sin square x by 2, cos square x by 2 minus sin square x by 2. Again here, 1 I can be written as 1 can be by using the identity, that is sin square x plus cos square x is equals to 1. Therefore, I can replace 1 by here cos square x by 2 plus sin square x by 2 minus 2 into cos x by 2 into sin x by 2. I can take cos function first here because here we have cos there. So tan square, tan inverse cos square minus sin square can be written as, by using the a square minus b square formula, I can written cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. Okay, divided by, here I can use the a plus b whole square formula. It can be written a square plus b square minus 2ab. Here of the form, that's why it can be written as cos x by 2 plus sin x by 2 whole square. So 1 square and this one square get cancelled. We have tan inverse of cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. Here I can divide whole equation by tan function. Then it becomes whole equation by cos. It becomes 1 minus tan x by 2 divided by 1 plus tan x by 2. Okay. Here 1 minus tan x by 2 divided by 1 plus tan x by 2. I can again, 1 can be written as, what is the 1? 1 can be written as tan pi by 4 minus tan x by 2 divided by 1 plus, here also tan pi by 4 into tan x by 2. By using the tan x minus tan y formula, the value becomes, here the value becomes tan inverse of tan pi by 4 minus x by 2. This is the final answer. That's why tan inverse of tan function by using the property We have only 5 by 2 minus x by 2. The option number B is correct. Usually this question will be asked for 3 marks in the annual exam question paper, but sometimes it may be asked in the examination. So you have to perfect the concept before going to solve all the competitive exams. Before you have to perfect all the basic trigonometric formulas as well as inverse trigonometric properties. Now let's move on the question number 3, 33. The set of values of x if tan inverse of x is equals to sine inverse of 2x divided by 1 plus x square wholes always. Okay, here this is the one of the property. This value is always holds when sine function is happens, the value mod x is always less than 1. Mod x is always less than 1. Similarly, here also there is the same question. If 2 tan inverse of x is equals to cos function, here cos inverse of 1 minus x square divided by root of 1 plus x square. Here there is a cos function. In place of cos function, then the value becomes greater. The option number C is correct. The set of values of x if 2 tan inverse of x. Okay. Here there is the same question. Sine inverse of 2x divided by 1 plus x square. The option number 2 is correct. Okay, again the set of values of x if tan inverse of 1 by x is equals to cot inverse of x. Tan inverse of x is equals to cot inverse of x. This is homework for you all. Okay, if you any doubt regarding this multiple choice questions, please contact us in comment box and send your doubt problems in comment box. I will make another one video and I will solve your doubts. If you really like my channel, please like and share my channel. Thank you. All the best for your exam. Okay. Thank you.